I am Laurynas Riauba from MetaSite, and today I will talk how to keep up to date in a bespoke software development world. So, I had a long way before I have settled myself into full-time professional development career. In the beginning, I was trying to find myself as an organic chemist. Later, I've turned to computational chemistry. Then I've shifted my career towards biotechnology. I was working as a research scientist, bioinformaticist. And during these times, I've seen how contemporary chemists and biotechnologists, biochemists, gene engineers are working in their labs. I've seen what problems they are facing. I've seen how biochemists are working with bacteria, how gene engineers are modifying the bacteria's DNA. And of course, every field has its own tools, which is specific for it. But we have our own tools, and which is specific for us. And we, as a developers, have something in common with the scientists. We want to use the latest technologies. We want to use the latest tools. So do scientists. They want to, let's say, chemists want to use the latest generation NMR spectrometers. Some want to use atomic microscopes. Gene engineers want to have sequencing machines in their labs. We want to use new frameworks. We want to use cloud. We want to use maybe AI or whatever technology comes to your mind. So what makes us slightly different? We as developers not only using these tools, but we are creating them. And we have to maintain them in an ever-changing world. So that's when the struggle comes. Sometimes I hear that developers are blaming or complaining that they want to use some new tools or new technologies, but, well, someone does not allow or forbids. Some like to dream about the company or environment where everything is on bleeding edge. So complaints and blames cannot change anything. But there is a path to change. We have to advocate our needs. We have to sell the idea that we need to keep up to date. So the situation reminds me the scene from the movie of Wolf of Wall Street, where the character played by Leonardo DiCaprio asked someone from the audience to sell him his pen. We are very much into similar situation. We need to sell the idea of upgrades to the clients, internal or external. And do you know what is the right answer for this sales instructor? I've read that from the real one, Wolf of Wall Street, which is the real person. And the answer is, tell me how long are you in pen business? That means start a conversation. In other words, before selling something, in this case, idea, we have to know what you or we are selling and who will buy. So it is a famous quote from Lord Byron: the best prophet of the future is the past. So let's try to learn something from the past to be able to change the future. And as an example, I've chosen some short history of Java. Well, in the beginning, there was just void. And later, main was added, and the first hello world appeared to light. So Java's beginning is buried in a dark, and well, maybe only some paleo scientists I'm not sure about paleontologist or paleocomputer scientist or astrophysicist can guess the reason why has Java one or another syntax. But I will skip the ancient history and the dark ages, and I will go towards nearer times. So the times were passing by, and much later Java 5 appeared, and then it saved Java developers from the tyranny of type checks. At some point, new winds started to blow, and Spring started to melt the permafrost of J2EE. Few years later, Spring broke down the chains of XML, and revolutions were that time common. Well, in the world as well. With Java 8, some pure energy of everything was flowing through with the streams of Lambda. But inequality among developers grew, and conflicts between functional programming style and procedural style programming adopters were quite common. Some other Java adepts were experimenting with Jigsaw, and eventually this led to the invention of some devastating power. This power destroyed RT-jar, so now we have only small parts of it. And the Java 11 detached us from the legacy, so hopefully now we can fly to the new haze. Okay, so Java has quite a long time, had a quite a long time to evolve into what it is now. But what are the main drivers and what are the main changes behind? So let's dig into it. Improvements in performance. They were substantial to compete with other technologies at that time. Let's say in the beginning it was C, later other languages. At some point, performance gains were such that, let's admit, nowadays most common Java developers are convinced in JVM supremacy. Well, high-level abstractions and new syntactic constructs can lead to better and cleaner code, some easier maintenance, less bugs, and maybe more robust code. But of course, we have to apply it wisely. The inversion control and dependency injection principles became common, and we do not imagine our lives without it. So if properly used, they promise better modularization and decoupling. So finally, some new standards, conventions in the APIs. Yeah, we have to admit that it is the largest part of the changes. So now we have huge development blocks and we can use them for free. So that is how we can deliver faster, we can have easier integrations. There are many changes, definitely, but I will not be able to cover all of them. So, okay, Java is changing, but why do we want to upgrade and why we should upgrade? There are some different reasons. Some reasons are pretty clear for business, not only developers, and can be presented in any situation. So let's say an example. Official support. Business will hear my back is covered by some big guys. Security fixes equals for them to am I vulnerable? Oh no, let's do something to avoid being hacked. And better performance might translate to the same hardware can be run longer, much longer, or it means just lower operational costs. It is expected that new features, libraries, and whatever you can imagine, they should reduce total development time and so the total cost. So this can be an argument as well. So some arguments most likely will be irrelevant to business. Clean and beautiful code should be at the bottom of the heart of every developer. But unfortunately, this desire might not be appreciated by all the business. Most likely, only few will appreciate, unless there is some trusted consultant which will advocate that. Maybe you will be lucky to convince business that it will be faster for you to develop the next solution. Well, and there are definitely some arguments which are important to the developer only. One thing, his or her morale. For some, it might be career opportunities. And I would highlight the last one. It should be especially applicable after the total failure if the version upgrade which you were proposing produces total disaster in production. And yeah, and don't forget, there are and there might be arguments to avoid the upgrade. Sometimes these are really valid, but we do not want to hear them. But you know, we have, or someone has to finally address them before business. So usually upgrades do not come for free, and there are some typical repeatable problems during the version migrations. In these cases, I will show some examples which are valid for Java 7 to Java 8 migrations. Some will be from Java 8 to Java 9 or 11, but most of the cases can be applied to the any version changes. So there are myriads of different JAX-B wrapper plugins for Maven and Gradle. So here you can see only I've searched it in Maven Central, and it is just half of them. Well, there are just different. You can see there are some different versions, but believe me, there are more. Even some repos have some others, and Gradle has his own versions. So some are supported, but others have been abandoned long time ago, so long before Java 8 made its way. So if you will find some abandoned plugin in your POM XML, so probably you might wish to summon some daemons from the past. JAX VS, the specification, APIs, reference implementations, they all come with a huge trail of transitive dependencies. And guess what? Just look at here. So there are some dependencies which are used, for example, for Apache POE library for XML, for XLS or doc file parsing, and some more, or even for security related. So we have to face the fact that we are heading into dependency hell. But yeah, don't relax. It's not only JAX-B who has Maven and Gradle plugins. Some plugins will be updated in the latest Java version, but you have to be patient. Wait till the plugin will be updated, and that might take some time, as our experience showed. But in the worst case, the plugins will not be supported anymore. Okay, so here we are coming to the essence of the upgrade. I mean, in the Java world. So the hardest part typically is a framework upgrade. So if you can upgrade your framework version, so that means you are almost halfway done. For the projects which were started during or just after the economic crisis of 2009, so that meant that might mean changing Spring 2.5 or 3.0 to some newer versions like at least 3.2 or later. But the same principles and the same problems apply to the migrations between Spring Boot. So between Spring Boot version 1 to Spring Boot version 2. There are a lot of things to consider during Spring Stack migration. One of them is Spring Security. Because Spring Security is an old, mature, and stable library, and it's very widely used. It has, yeah, admit it, it has great support, and it can be tuned to adopt almost any variation of software security setup. But even with the best intentions, Spring Security developers have to change the APIs. They have to, maybe sometimes they deprecate some features. They are renaming the classes, they are changing the parameters and packages. So if you have some fine-tuned security setup, it might be scary to change something. But in general, but if you're thinking with security, it might be even more frightening. And well, it might lead to some another security audit or penetration testing. With a major Spring version update, it is allowed to move some packages, and classes can be relocated to the new places. So there might be some important changes to the used underlying libraries. Usually that shouldn't be the showstopper, but who knows? Maybe some developers before you silently made their own extensions to this. So don't forget, Spring heavily relies on bytecode magic libraries, and these might collide with some another dependencies. And well, last but not least, you might be forced to deep dive into Hibernate, Query DSL, or Duke upgrade. From these, Hibernate updates stand out. Maybe you have some, I don't know, some superpowered ID generator, or maybe you have implemented some custom naming strategy for your mainframe database, or maybe you have some unwritten rule to use everywhere positional params. So in this case, you will have some nightmarish migration. So if we can cope with such upgrades, so upgrading to Java 11 or later will be just a breeze later. But you have to wait till the dust settles down. Probably later you have to play with Maven or Gradle. Maybe you will have to add some dependencies or remove others. Probably you will need to get familiar with the new syntax and the latest features of Gradle version. Theoretically, it might look that there might be many scary scenarios, but the reality is much more boring. So I will present a few of the scenarios which happened to us. One of such scenarios might lead to the infamous no such method exception, which happens when some classes are duplicated in few jars. Most likely this can happen if the artifact is renamed or the artifact is moved to another group. And usually build tool resolve some dependency issues, but in this case it won't help. So here you can see that we had a situation when there was a 1.3 and 2.0.5 version were present in the same WAR file. So frameworks and libraries can change the names of configuration keys, and you might be unaware of such changes. If these properties are modified for production environment only, so then you might easily miss them and your test will not find them. So you will get some error in production. In our case, we had some problems where we missed that servlet param was changed, context path. And there might be some other cases. Probably you might have your own stories. But there are some certain things which can help you. Version upgrades are much easier if you sit on a quality code and applications are relatively small and modular. But it's not always the case that you have written them. Sometimes you are sitting on some legacy code. Probably you will praise the architect or maybe yourself if your application will follow DDD-like approach, or at least the framework internals do not leak into the main model. Do not underestimate the power of tests. Having unit and integration tests directly translates into confidence and good night's sleep. So if you write them, then it's very good. But don't forget, the more you have, the better. But just bear in mind, for version migrations, the integration tests are more important than unit tests. They will show what happened and if your version upgrade is successful. If you are able to install or select Java version on server, or maybe your solution already is containerized, that's even better, then you will be able easily switch versions. And sometimes this is inevitable, especially in the case you are heavily working in a parallel development. On the dark side, there is opposite things. So no test or bad quality tests, tight coupling between framework and business logic may force you to just give up the migration. Immature libraries or inactive projects can be used in few cases. So you like to live on a bleeding edge. You are developer of some library and you want to promote that library. Or maybe you are creating the proof of concept. But none of these apply to the software which should be supported for a long time. And in case you are working in a project or a company where the FDD style is the most popular one, so probably migration just will not be done. It is said that it's easier to give the advice than to apply it. But nevertheless, here I have some tips. The first one is prepare. I know that reading good documentation and usually there are lots of letters of and some boring test and migration guides, but these will help you in the long run. At least try. Detect what should be done before the actual migration. There are some tools in the wild. Here you can see some of them. You can Google some more. And yeah, I know it's boring to hear again have tests, but some truths do not get out of fashion. And one more, don't do it in one big chunk. Just try to split it, and small steps are better for these migrations. It might look that upgrades are very time-consuming task, but in reality, at least for us, it's not that bad. Typically, it takes 1 or 2 work days, and there might be a need for a few to fix few bugs, but usually these are the subtle ones. Okay, so is the bespoke development that different? Software development companies in general, they are different. But there are some types of software houses, and they have some traits in common. So products and companies can be classified according to the various criteria. One of them is orientation to the product or productization. So some companies are working on a product, and it's like a car factory. They produce mass product. Some others are working on custom tailored needs. So for me, this resembles bespoke software development resembles this fine-tuned custom cars, building them, tuning, and well, finally, there is a big need to support these mass products. So for all of these types, there are some types of companies. So here you can see some more examples how classification can be done. Some companies or services are big, established and used by many. Startups, they have their own specifics. By definition, they should be agile, and the lifetime of the software is rather short. I think that they shouldn't think about the version updates at all. And there are myriads of companies which help to solve specific problems arising to the business around the world. Tech giants are setting the trends for the software development. They are present in the conferences, they have champions, advocates, they promote their software stacks and tools. I have calculated that on average, one developer might be responsible for thousands or hundreds of thousands or even maybe millions of end users. So obviously, financial pressure and the challenges for the big companies are quite different than in bespoke software development. So the approaches used by the Google, Facebook, Twitter, Netflix, and the others are not always applicable to the common custom software cases. So I have found some interesting facts related to this topic. So did you know that it is estimated that currently there are almost 20 million developers, and most popular languages for now are Java, C#, JavaScript, and Python. Seems that Python and JavaScript are the first two. Regarding the countries, so California alone has more than 500,000, and Germany, let's say, has approximately 800,000 of developers. But of course, the numbers might depend heavily on the calculation method, but the trends are there, and we can feel how it's that. So back to bespoke software development. Here you can see the extreme example of the project setup, but anyway, it gets to the point. So in general, custom software development faces high pressure on the budget, and I think it's obvious why. So this leads to searching for a local minimum in the bespoke software development in comparison to the global minimum. So as a consequence, tight budgets and client orientation towards highly specific goals do not encourage developers or the project owners to maintain the software and to keep it up to date. We have to promote that from ourselves. And here you can see what are the typical or the average aspects in the bespoke software development we have to consider. Some of these aspects might be relevant for ones, the other ones might be relevant for others, but in general, I think these should cover most of the cases. Projects are relatively short, at least for us. But the expected shelf life is quite long. So do you remember which technologies were used 10 years ago in 2009? Probably jQuery, maybe some were doing with JSPs. So the good thing in bespoke software development is that we are not that constrained with the version policies and the technology policies by itself. We just have to use established technologies. It's quite usual for the client to want established technology, maybe to in-source the solution. Custom software development has quite pronounced activity patterns. So initially, there is very high activity, but unfortunately, there is no real feedback from the users. After the initial release, we have few hot months where the change requests are coming, and then activity settles to some background level. And then sporadically, every several months, we have some spikes in activity. So in general, it's easier to sell the idea of the necessity of version upgrade during the peaks of the activity. So on the left side, we have I have an example. So at the beginning of 2016, we were able to migrate Java 7 to Java 8, but unfortunately for another project, it was the beginning of 2015. Java 8 was relatively young. Not all the plugins or the libraries were there, and we missed that release, let's say, version upgrade window. And guess what? We had to wait almost 3 years to upgrade to the Java 8. But anyway, I think we can find some better or worse windows. Before I was the slides before I was using Java development as an example, but with Java there is something more. Usually these topics are too broad, so I will not go into details this time, but I will show our path to the containerization. So initial driving force to adopting containers was the need to solve problems with shared development environment and integration test databases. I think that's pretty common. Initially, we've tried Vagrant, but somehow that was maybe too heavy and no one used it. Nowadays, setup with Docker Compose is common, and especially when the developed solution has some applications, let's say front-end application, back-end application, one or two databases, and maybe some sidecars. Probably you already know that there are few things to consider. With Docker, we had the biggest issues for the, let's say, for the development environment with the configuration of the networking, and sometimes there were some issues with the storage. The next step was containerization of internal development tools like Jenkins, SonarQube, some Git things, Artifactory, and so on. So few advantages. It's easier to maintain these tools in a containerized environment. And secondly, it's a nice sandbox to just to learn about operational aspects of working with Docker and what can go wrong with it. So it's a good sandbox. Another positive side effect is that developers are forced to know to Nginx, load balancing, proxying, and so on. So running the naive Dockerized setup in production, we've tried it as well. So it has some advantages and disadvantages. It can easily be set up both on-premise and on cloud. Its computational overhead is negligible. And at last, infrastructure can be versioned in your versioning system. On the other hand, it's too easy to mess things up, and operational security as a whole can be questioned on that setup. So this approach can be recommended for small projects only. So I want to point some situation with Docker Compose. So running Docker Compose down and then adding minus VF flag can do amazing things. So finally, deploying application to the Kubernetes cluster. It takes some time to learn this powerful tool, but after some time, the efforts pay off. So what you can do with that? You can do some rolling updates. You can create a new QA environments as much as you need it. But be warned, running on Kubernetes brings some computational overhead, and it requires some mind shift. But again, usually developers are happy to gain some DevOps skills. So yeah, Kubernetes is cool and it's trending, buzzy, but will it solve our problems? If you are attending conferences, reading some magazine, news, white papers, and so on, they often claim that there is some silver bullet to solve scale issues. Big scale companies or maybe the government sites, they definitely have to solve scale issues. Startups, on the other hand, they are expecting to solve scale issues at some point. But does it apply to the bespoke software development? Well, the essence of software from the beginning was the automation of some process. And in this case, for the bespoke software development, usually it is a business process. Let's dig through some examples to analyze what is a typical bespoke software. So it might be business support system. It might be document management system. It might be self-care. If you will check through your own list of the project, you most likely you will see that all of them need few CPUs, maybe 2 or maybe several gigabits of RAM, but nothing special. Okay, let's say there are other types of custom software like billing, CRM, ERP, something like that. But again, few CPUs, several gigabits. And okay, admit that it's a common bread for bespoke software development integrations. The essence is the messaging in a broad sense, transformation of the messages, logging, and something like that. But this does not require higher computational resources either. So requirements are much like before. So, okay, maybe in the business we have some strict availability requirements. From our experience, it appears that high availability requirements most likely fall under the should or could in the Moscow system, but not on the must. But just to note, of course, there are some projects and some software which do need some really high availability or whatever requirements. So it appears we are doomed to keep away from such trendy technologies, but I've told before that we are already using Kubernetes, we are using Docker. So indeed, in fact, it boils down to the operational and deployment aspects. Bespoke software development, by the definition, should be diverse. We might run on cloud or on-premise, we might run on Windows or Linux, and so on. And the operational setup is different, and it's hard to maintain homogeneous setup. So the main driver to adopt all the mentioned technologies was the need to have some operational common ground, and what's more important, to adopt good development practices. Okay, so I will just wrap up. Keeping up to date is good for developer morale, but being up to date requires some effort. We have noticed that transitioning to the state up to date has some positive side effects. But I have to warn you that any journey involves some risks, and well, with great power comes great responsibility. And the last one, we have to question everything and critically accept all the statements. May the most recent version be with you. Questions? I think there are no questions, so we can go to the... Oh, we have some. Okay. Okay. In our company, I think we do not have such. But in fact, the companies which have some legacy code, they do have problems. All right. Yeah, we have won that project. It's still not migrated. It was written in 2008. Some time in 2011, there were some junior programmers alone working on it, and it's in pretty bad situation. The logic, business logic, is tightly coupled with the framework, and the client is very demanding. So it's kind of, in a sense, it's a fear-driven version migration avoidance. But I know that from some friends of mine that there are some companies which do like to blame developers for producing some errors, and they don't want to fix on that, learn from the errors, but they are just blaming each other. But yeah, it depends on the company. Okay. That's it. Okay, let's go to lunch.